All right, so we have Geometry, Module 2, Lesson 3, Explain 3, specifying rotation angles. So find the angle of rotation and direction of rotation for the given figures. Point P is in the center of the rotation. So we have our shape and we have our other shape. And what we want to know is by how much was this image rotated, the pre-image rotated to create the actual new image. So you can draw segments for the center of the rotation to a vertex, again it doesn't matter which one, of the image of the vertex. So you're going to draw and measure the form of the segment, and the angle measure is 80 degrees. Compare the locations of the pre-image and the image to find the direction of rotation. So you have to say, okay, well this one was the pre-image, this one's the image, so we're going counterclockwise. But otherwise you drew the line segments, connecting them, lay down your protractor and measure it from 0 all the way up to 80 degrees and go, okay, well apparently it moved 80 degrees counterclockwise, and there is your answer. Right, next page. On your line segments, make sure you get your protractor out. Pay attention to which one is your pre-image and which one is your image. So then you can kind of make a mental note as to which direction you're going. And so traditionally you want to also kind of put your 0 down on your pre-image to see the rotation from your pre-image. I mean, in honesty, not really a difference, but it's just kind of good because then you're also following the concept of the direction that it went, so you don't get those confused. So this is obviously a clockwise, and if you measured out on your protractor, if you haven't already, make sure you pause the video and do so now. Check your answer. Should get 135 degrees clockwise. And you're finished. Right, so let's look at our reflection. So does it matter which point you choose when you draw a line segment from the center of the rotation of the points of the pre-image and image? Explain. So look back on there, and does it matter which one you choose when it comes to doing your measurement? Okay, and again, you're just after the basic concept. No, as long as the points are corresponding. A point and its image. Okay, the angle of the rotation will be the same. Okay. And part A is a different angle of rotation or direction possible. Explain. So look back. Is there another bit of directions that you can give somebody and say by, again, counterclockwise or clockwise and a degree that would allow you to rotate the shape by the same quantity and get in the same spot? Okay. So is there another way that you could do it and get it in the same spot? And yes, a rotation of 80 degrees counterclockwise is equivalent to the rotation of 280 degrees clockwise. Remember, it has to add up to 360 degrees. So whether you go one way, it's only 80 degrees. But if you go the other way, counter or clockwise, it's 260 to meet at the same point. Okay, your turn. So find the angle of rotation and direction of rotation for the given figure. Point P is in the center of the rotation. So we have number 11. And you have your two shapes. So if you pause the video If you need to, you are welcome to even go back over the previous points and re-watch those, or look at the back of your previous notes to figure it out. Right? So let's go ahead and check your answers. So the transformation is 70 degrees clockwise rotation. So to go from, we'll just say N to N prime, you should have put down your protractor and realize there was a 70 degree difference between those two vertex or vertices. Alright, let's look at the next page. Rotation and an angle of rotation. What steps can you use to draw the image of the figure under the rotation? So think about that. If you are given a figure, a center of rotation, like we had in our previous problems, and the angle of rotation, what would you do to draw the image that you'd get after completing that center of rotation, or excuse me, that rotation? So pause the video, copy down the answers, look back over it, and practice. This is practicing the process of being able to do it. All right, let's check. Again, these are sample answers. So if you wrote yours differently, but the concept is still there, that is perfectly okay. Suppose you're given triangle DEF and triangle D prime E prime F prime and point P. What are two different ways to prove that a rotation around point P cannot be used to map these two triangles onto each other? Okay? So what you could do is show that the actual line segments, the distance between them was not the same. Because remember, the central point to any vertex has to be the same between the image and the pre-image. And if that's not the case for all the things, they all have to have their own unique distance, but they have to stay consistent, then the shape was distorted or spun out of the way or flipped or something else was done to it. Right? You can also show that the angle was not congruent. They did not rotate at the same degree. All the angles, all the vertices have to rotate at the same degree. Okay. Essential question check-in. How do you draw the image of a figure under a counterclockwise rotation of 90 degrees around the origin? Okay, so think about that for a moment. Write your answers. Don't overthink it. Pause the video if you need more time. Otherwise, here is the rule that you would use to be able to plot the points and connect them to create your figure. Alright, I hope this helped.